This video is one in a series on streamlining design in AUD. In this video, you'll learn how to perform table-driven selection of components, instead of having to set defaults. This will include steps to add a standard duct model attribute to the table of cable models, to create a rule that leverages this cable data to select the right duct model, and how you can simplify the electric underground pull-down to avoid designer confusion. Within many utilities, some components are selected based on tables. One common instance is duct selection. Utilities that use this approach generally only put one cable in each duct, and the size of any given duct is entirely determined by the cable contained within the duct. You might see a table like the following. There are several ways to accomplish automatic duct selection, but the core to implement this is that you need a table to indicate which duct is appropriate for each cable. Great. So does this mean you use the AUD table function to create such a table? No, this isn't the best approach. You already have a table you could use, the table of the conductor models. I'll start the industry model editor and select the conductor table. I'll switch to the attributes tab. Now I'll add a new model attribute field. This will be a model attribute as the values are specific to each conductor model. I'll make the caption standard duct. The data typed will be text. I'll name the column DLC STD duct. I'll add a description and I'll set the category to 3: specifications. Next, I'll add values for every underground cable with valid duct model names. I won't bore you with the process, but now in my conductor table I have the standard ducts for each table. The next step is to create a rule to automatically select the right duct. I'll open the rule editor. So, question 1, what kind of rule do I need? In this case, I need a sizing rule because I want to automatically select the right size duct model. Note, it might help if you think of the sizing rules more as selection rules, because that's really what they do, is help select a specific model. I'll expand sizing rules and I'll choose structural because ducts are structures, line string because ducts are linear objects, and I'll select the duct rule you find here. The first thing I'll do is to disable the current sizing rule. This rule looks at the contained cables and calculates the minimum diameter to contain those cables. Why not just delete it? You can, but just in case you want to refer to it later, I tend to like to disable these instead. My method of disabling rules is to create an if statement as follows. This rule will always be true, and then I'll put the existing rule into the else part of the if statement, so it will never get executed. I'll add a comment to remember this is a disabled out-of-the-box rule. Writing the new sizing rule is the tricky part, so I'm going to talk you through this carefully. Sizing rules are based on setting filters that narrow the range of possible results. You may have dozens or hundreds of models, and you want to filter that list down to ideally the right one selection. In this case, it's easy, because you have a field on your conductor that tells you exactly what model you want. I'll add the basic filter rule. I'll filter the ducts based on model name, because I will know the exact model name. And now we come to question 2. This rule is about ducts. How do I get the recommended duct value since that data is coming from the conductor? To do this, you'll need to use what's called an aggregate function. Aggregate functions work when there are multiple choices. In this case, there might be more than one cable in the duct. Now you may be thinking, but in my utility, I never put more than one cable in the duct. And that may well be true, but within AUD, it's technically possible to have more than one cable in a duct, so you have to write the rule to take this possibility into account. I'll write the rule and then explain it. I'm going to choose the aggregate rule first. I'll change this field to conductor because that's the thing that's contained in the duct. I'll change this next field to contained features because the relationship between the duct and the conductors is that the conductors are contained within the duct. And for expression, I'll choose standard duct because that's where the data indicating the correct duct will be located. Why did I choose the first function? Because designers should, in this utility, only be putting one cable in each duct, so the first cable will be the right one because there should be only one. Before I continue, let me explain the difference between a hack programmer and a good programmer. A good programmer asks, what could go wrong, and plans for every contingency to assure that this rule will always work. In this case, what might go wrong is that the designer uses a different command and places an empty duct. In this case, there's no contained cable, and there's a chance that this filter will fail because there's no contained cable. So here's how I'd improve my rule. I'll create an if statement. For the first parameter, I'll choose the general function number of contained. I'll switch it from access point to conductor. The where true part here allows me to filter the contained conductors. I'll choose the subrule is cable because for my rule to work, I need an underground conductor, i.e. a cable. And I'll set the operator to be at least. I'll expand the statement and drag my completed sizing rule into the then part of the statement. Now the rule won't have a problem if for some reason an empty duct is drawn. Now I'll go test the rule. First, look at the defaults for the primary duct. Currently, for primary conductors, the default duct is sent to a 2-inch model, AUD 240. Let's draw a primary underground cable. Here's the conductor. Note in the specifications section, it indicates that the default duct is AUD 380. And if I look at the duct model selected, it is indeed a AUD 380, not the default AUD 280. The bottom line here is that instead of needing to specify a default for both cable and duct, all I need to do is choose the conductor I want, and the duct size is automatically determined. Now before we finish, you might want to do a bit of cleanup to avoid confusing designers. Editing the default screen has already been covered in other videos, but quickly I'll show how you can use the AUD options command to remove the duct selections from the default screen. I'll choose the AUD options command, expand default profiles, and choose the default profile. I'll expand the collection. Then I'll select underground primary and expand that collection. I'll now select the duct field and click on remove, and then I'll click on OK. I'll do the same thing to remove the duct field from the secondary underground section and also from the service underground section. Now that this is done, let's click on OK to keep our changes and check out the default pull-down again. Now you can see that the unnecessary duct values have been removed to simplify the screen and reduce potential confusion. Finally, here's a couple things to note. First, this approach can be used for other table-driven component selections. For example, you could automatically select the appropriate pad or volt for underground transformers, switches, and junctions. If your utility sizes service cables based upon meter or panel size, you could perform this selection automatically as well. And one further note is that you may need to consider what happens when there are exceptions. For example, what happens when a designer wants to deliberately oversize a duct? There are several ways to handle this type of exception, but that topic will have to wait for another day.